Very good. Very good.
But it won't have a secondary root, will it?
Why not?
Oh,
That's okay.
yeah.
That's okay.
Sorry, yeah.
No problem.
I was thinking just taking the root of the denominator would give you 1. Root of that would be 0, but that's not how it works in a ratio.
Right. Like me with a plus. But it's clearly minus. Okay, very good. So now I'm looking at the limit. X approaches not 0.
1 from the left and 1 from the right.
2.
0.
2 from the left. Yes, which is x squared plus 2x plus 1 divided by x minus 2.
So why not 0?
Because 2 is where it's undefined.
But 0 is not a limit. When I plug in 0, I get negative 1/2. So I need this, 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 and the x-intercepts. Okay? So limit from the left of 2. I know the top is 4 plus 4, 5 plus 1. 4 plus 4, 5. Wonderful. 4 plus 4 is 8 plus 1 is 9, so it's positive. And the denominator is 0. But 2 from the left will be 1.9 minus 2. So the answer is? Then limit as x approaches 2 from the right, from x squared plus 2x plus 1 over x minus 2 is still plus over 0. But 2 from the right, positive, right? Good. Okay, now I want to find, yeah, infinities. Let's do that. Limit as x approaches negative infinity from x squared plus 2x plus 1 over x minus 2. The top approaches, yes. The bottom approaches, right, it doesn't matter. What method do I apply when I have infinity over infinity? L'Hopital's rule. So then limit as x approaches negative infinity from the top, which is, yes, and the bottom, which is 1. So then the limit is? So now limit as x approaches infinity from x squared plus 2x plus 1 over x minus 2. I will differentiate in the same way because it's infinity over infinity. And I get 2x plus 2 over 1 as x approaches infinity. The limit is? Good. I need to determine, so obviously x equals 2 is a VA. And I need to find f of x equals 0, the x-intercepts. So a fraction is 0 only when? Yes, but that factors into x plus 1 squared equals 0, so x equals negative 1 twice, which we know is from pre-calculus. Multiplicity 2 is always a term, which will be a max or a min. But we'll see this with the first derivative. If you don't remember this part, it's fine. We still have the first derivative. So at negative 1, the function is 0. I know that this function has a slant asymptote, and now I have to find the slant asymptote. Find slant asymptote. In order to find the slant asymptote, we can use long division. That works in all cases, and in limited cases, synthetic division. Synthetic division works only when I have a polynomial divided by x minus a number, which is our case. So we can use synthetic or long, and you tell me what you want.
Oh, I don't know how to do either one. So.
Okay, we can do both. So I have to divide x squared plus 2x plus 1. X times what is x squared? Good. I go back and distribute to both terms. X times x is x squared, and I have to change the sign. Negative 2x, and I have to change the sign. 4x plus 1. X times what is 4x? Positive 4. 4 times x, and I change the sign. 4 times negative 2, and I change the sign. So this division of x squared plus 2x plus 1 over x minus 2 is x plus 4, the quotient, plus 9 over the remainder. I'm sorry, the remainder over the divisor. Any questions? X plus 4 alone, not this, is the slant asymptote. So far, where is my function? Like 10 pages. Okay, so I know that x equals 2 is a VA, and I know that y equals x plus 4 is an SA. I'm done with this. Now I'm moving on to this. So f prime. The top prime, 2x plus 2, times the denominator, minus the top, times the denominator prime, over x minus 2 squared. Okay. 2x times x, 2x squared, minus 4x, plus 2x, minus 4, minus x squared, minus 2x, minus 1. And I bet nothing cancels. Oh. Okay. So this is x squared, minus 4x, and minus 5, over x minus 2 squared. I'm absolutely brilliant. I have no idea how I picked this function. I just made it up. But the first derivative has 2 solutions. Absolutely brilliant without effort. So f prime of x is 0 for x equals 5 and x equals negative 1. I don't even know how I got that. Oh, I knew that negative 1 has to be there, obviously, which we discussed. It's a term. And then 5. So now I'm trying to find the sign of this expression, but I'm not going to be bothered by the denominator. And the numerator, remember, is this function, and it has a minimum, and it crosses at negative 1 and 5. So positive, negative, positive. Oh, you're just punching numbers. Okay, moment of truth now. I don't even want to look. Okay. From negative infinity to 0, the function is correct? From 0 to negative 1/2, the function is? From negative 1/2 to negative infinity, the function is? I have to find this value though. Okay, what is it? 25, 35, 36 divided by 3. Oh my God!
Why do
12.
we have the x value of 0 in there?
This one
No,
is for the
for
derivative.
x on the top one.
Oh, we already knew that this
No,
was
like when x is 0 and it equals negative 1/2, where did that one come from?
0, 0, 0, negative
I just
1/2.
don't remember doing that. Like,
It's the y-intercept when x
oh,
is 0.
yeah. Okay.
That, right?
Yeah.
Good. So now from positive infinity to 12. From 12 to infinity. Now, Sarah, which part of the chart so far is not clear?
This makes sense now.
Ah,
That's our turn.
good. I'm happy. What am I doing? Which page am I on?
84.
29.
Okay, I'm on page whatever. Okay, so now this was the second derivative.
But I wrote the second.
This was the first derivative. Now I need the second derivative.
Oh my god.
Yeah, that's my point.
Alright.
The top prime, 2x minus 4, x minus 2 squared minus x squared minus 4x minus 5 times 2 times x minus 2 over x minus 2 to the fourth. One more time, the key word is, if I don't, I'll never get anywhere. So at least an x minus 2 is out. I should have taken a 2 as well from here and from here, but I don't want to confuse you. So 1 is out, but I still have this and this. So x times 2x, 2x squared, minus 4x, and minus 4x, and then plus 8. This is out. So minus 2x squared plus 8x plus 10.
So all the x's go away.
So 2x squared minus 4x, I'm just checking. Minus 4x and plus 8, and this is out. So minus 2x squared plus 8x plus 10. Yes, these two. Good.
And
To tell you the truth,
Negative 4x and 8x goes away, and 2x squared goes away.
we have the negative 4 to go
Yeah,
these two with this. Negative 8x with positive 8x. Very good. Gee. You know why I split it? Because I need to study the sign. It's never 0, no inflection points, but this is a positive number. So only this to the left of 2, it's a linear function. To the left of 2 is negative. To the right of 2 is positive. Ready?
Yes.
So when we graph a function with asymptotes, we have to graph the asymptotes first. So this function has a vertical asymptote at 2, and it has a slant asymptote y equals x plus 4. When x is 0, y is 4. When y is 0, x is negative 4. Two asymptotes, the slant and the vertical. And now I read my chart. I'll be ready to read the chart. I have to plot negative 1 comma 0. I have to plot 0 comma negative 1/2. I have to plot 5, 3, 4, 5 comma 12. I'm going to say this is 5 comma 12. Sorry. Ready? Okay, here's how I read my chart. From negative infinity opening down, crosses at negative 1, 0. Oh, I forgot to mention, this is a local max. And this is a local min. This has to be in the chart. Okay. So opening up comes to this, but it turns. It's a turn here, negative 1/2, negative 1. So coming from negative infinity, the function turns at this point. It comes down to cross at 0, negative 1/2, still opening down and going towards negative infinity on the left-hand side of the vertical asymptote. On the other side, it's coming from positive infinity, opening upward, decreasing to 5 comma 12, and then continues to open upward, going to infinity. From approaching the asymptote, comes to a minimum, and goes up.
So, oh, well, I just asked that.
Is this okay? Okay, with the graphing calculator, please. In y equals, we have to put two functions in. What do you think we have to put in?
We're gonna put y equals x plus 4.
Exactly. Very good. Please put parentheses and x plus 4. I will use the standard viewing window, which will not be good enough, however, because the minimum is at 12. So I have to change that.
Is there any way to change this to plot the vertical asymptote line?
Yes.
To make it x equals 2?
Yes.
Is it a pain?
No.
Okay.
Do I remember how to do it right now? No.
Okay.
See, my calculator doesn't have that. So in my calculator, for example, if I want to graph, let's say x minus 1 divided by x plus 2, I know the vertical asymptote will be at -2. So I will put zoom 6, and here it comes. So here it is. That's the vertical asymptote at -2.
Oh, it just kind of plots it for you? Or?
Yeah. And of course, I should have plotted also the horizontal asymptote. But it automatically does it. So that's why I never really investigated, but there is a way. Okay, with a viewing window, let's see what I want. I want negative 6 to positive 6 for x, something like that. Negative 6 to positive 6 with a scale of 1. But when it comes to y, I don't think I should go lower than -4, but I need to go higher, like let's say 30, and with a scale of 5. And I will put, because I want to see it turns at 1, -1, I'm sorry, and here is the minimum. So maybe I should go and
Yeah, switch over.
It shows up really good if you do it. I think I did mine 20, -20 to 20, and -20 to 20.
Okay. Fine.
Shows
So-
up really good.
-20 is too much, but that's fine. I'll do.
Well, yeah.
That's fine. With a scale of 5. And y minimum, you want also the same thing?
Well, I mean, it shows it. I just
That's
put it
fine.
in really quick, and it shows them.
That's fine. I wanted to with a
And
scale
it
of.
keeps it in the same proportion that we're used to.
Okay, very good. Here it is. Here's the slant asymptote. So this is a function with a slant asymptote. Why? Because the difference of degrees is 1. The top is higher by 1 than the bottom, not the other way around. The other way around, it has a horizontal asymptote and it's 0.
If it were a negative, would it be the other diagonal?
Yes, if the leading coefficient is, if the slope of the line
So
is
negative
negative, yeah, it will be like
over
this.
x.
Yeah, it's negative x plus 5. It will be like this. That's a function with a slant asymptote. Okay, what do we have about half an hour or so. What do we want to review next?
Start at the beginning.
Which one?
You want to start at the beginning?
Sure. So let's go back to the review section. Do we still need to use L'Hopital's rule, or are we okay with L'Hopital's rule?
No, you
Yeah, I just have to remember that you can do it repeatedly.
You have to do it.
So
until you get the
Yeah.
top zero,
Right.
0, yeah.
Good?
So,
Yes?
What page is the review on? I'm sorry.
The review is on page 352.
so So one interesting thing that I just realized, I'm not sure if it's interesting to anybody else, but I think this has a little bit more to do with Rolle's theorems and its play in physics, right? So say you have an apple, right? Throw it up in the air, and you're measuring the relationship between the height and the time, right? So when you throw it up and it comes back down, before it left your hand at one point in time, when it comes back at some point in time, that relation using Rolle's theorem lets you know that when it hits the top, that's when the velocity of the apple
Becomes 0. Right. And it comes back with the same. Yeah.
just point it.
I guess we can do one for six.
I mean, if we just go through like the roles.
Yes.
Mean values. Let's see.
We do like number 2.
Yes.
Just do one from each section.
Sure. So we're looking at problem 2. Find the local and absolute extreme. So that's not Rolle's theorem.
It's fine.
Oh no, I was just suggesting that.
Oh, yeah, of course.
Section.
You want to work on number 2?
If we do one,
Oh,
one per
absolutely.
section, we'll get
Very
some
good.
Rolle's value and mean value.
Very good.
That's fine.
So we are looking at problem 2 on page 352. Yes? Very good. So then f of x equals x, the square root of 1 minus x, and the interval is negative 1 to 1.
You're on the computer, right?
Of course. Not surprised anymore. So what do we do? First of all, this is a situation in which we are asked to find the max min of this function, study this function only between negative 1 and 1. We're not asked to graph it, so I will not here add the second derivative. There is no need. So I will find the first derivative. I will set it equal to 0. I will see when it's undefined. If I find that the first derivative is undefined when the function is defined, then that is a critical number. And then I will study the sign. So let's work on this for 1 minute. See what we get. And I will put my attendance in when you do that. And of course, I'm logged out. Can we start? You need more time? So I need to find f prime of x. First of all, I look at 1 minus x, and I know that 1 minus x has to be greater than or equal to 0. I move negative x, so x has to be less than or equal to 1, which is okay. Just checking. So then f prime is first function prime, 1, the square root of 1 minus x, minus x times 1 over 2, the square root of 1 minus x, times negative 1. So this is the square root of 1 minus x plus x over 2, the square root of 1 minus x. I have to find the common denominator, and I have to multiply this by 2 times the square root of 1 minus x. So this is 2 minus 2x plus x. Therefore, I get 2 minus x over 2 the square root of 1 minus x, or negative x minus 2 over 2 the square root of 1 minus x. Have two problems here. X cannot be 1. And if f prime is set equal to 0, then x equals 2, which is not in the domain. It's outside. But I have to write that the derivative is undefined here. I have to plug in negative 1, and when I do, I have the square root of 2. I have to plug in 1, and when I do, I get 0. And basically, there is nothing else I can plug in. And now I'm looking at this.
Well, isn't it the negative square root of 2? Plug in negative 1?
In here?
Yeah.
So when I plug in negative 1. Oh, yeah, because this is negative 1.
Yeah.
Thank you. Very good. Yes, thank you. My apologies. So now I have to study the sign of this. And I know that this is always positive. And I know that this will be 0 at x equals 2. So to the left-hand side, I'll plug in 0. When I plug in 0, it's positive. So the only thing is, this is an absolute minimum, and this is an absolute maximum. So negative 1 comma negative the square root of 2, absolute min, and 1 comma 0, absolute max.
So looking at the function though, if you put x at 0, then f of x is 0.
Right, but we,
I mean, that's a point in the middle, right?
right,
So doesn't it have to do something else somewhere?
so
So if negative 1 gives you the negative root of 2, and then 0 gives you 0, and then 1 gives you 0, it seems like something should happen between 0 and 1 that takes it either into the positive or down to the negative.
it's a very good point, but since the first derivative is always positive,
And can it just stay on 0, like stay on
right,
0?
but that will not be a man or a max or a min. Excellent.
Okay.
Excellent. If the function is always increasing, for example, x cubed, follow my hand, x cubed. It has no max min, but it has an inflection point at x cubed, for example, and it's 0 at x equals 0. So since there is no sign change in the derivative, even if it crosses at 0, 0 cannot be 0 comma 0. The origin cannot be a max or a min, because the first derivative is always positive. So now let's graph the function. We can find the second derivative if you want, but let me go to the graphing calculator. We can do that if that's what you want. So in y equals clear, and I have x the square root, parentheses 1 minus x, close. And I just want to see it according to this between -1 and 1. I'm not going to spend time on anything else. So -1 to 1. And I'm going to, I know it's between negative the square root of 2 and 0. So I'm going to graph it between the -4 and 4 for y. Oops, I didn't mean that. -4 and 4 for y with a scale of 1. So graph. It appears that so the function is increasing. I did graph it between -1 and 1. Yes, didn't I? And -4 to 4. Unless I made a mistake in my derivative. If I made a mistake in my derivative, then the whole thing changes. Let me do it again.
Well, actually, when you take the first derivative, I got square root of 1 minus x minus x over.
I like to check everything from the beginning
Okay.
because I just want to make sure now. So I have the first function prime. Right. I got it. I put minus instead of plus. So the whole thing changes. So f of x equals the square root of 1 minus x. I'm telling you, my pluses and minuses tonight are not in order. So the first function prime 1 plus x times the second function prime, which is 1 over 2 the square root of 1 minus x, times -1, which is 2 minus 2x minus x divided by 2 the square root of 1 minus x, which changes the whole thing. 2 minus 3x divided by 2 the square root of 1 minus x. And this is 0. F prime of x is 0 when x is 2/3. So now all this goes away. Thank you. So then x, f prime of x, f of x, and I don't need the rest unless you want to find it. So this is between -1 and 1. And at -1 we have found negative the square root of 2. At 1 we found 0. And at 2/3 the derivative is 0. This is always positive. Before 2/3 is positive, after 2/3 is negative. So now I have to plug in 2/3 in the function. So I'm going to plug it here because I have it. So second and table, and I'm going to put 2/3. And I get 0.4 roughly. So from negative square root of 2 to 0.4 and then decreasing. And that's what it shows here. So this is an absolute minimum, -1 comma negative the square root of absolute min. 2/3 comma 0.4 absolute max. And 1 comma 0 is nothing. Thank you very much. Thank you. Is that what you meant to say, Chris?
Oh, yes.
Okay, sorry about that. So that's why this function has this graph. It's between -1 and 1, increasing till the point of maximum, which is the absolute maximum, and then decreasing. That's why this is the absolute minimum and this one is nothing. Thank you. Thank you. Good. Anything else? Do we need more limits? I know we are done with graphing. Do we need more limits? Any of those, 7 through 14.
Could we do 9?
Yes. So let's look at 9. Do you want to work on 9 for a minute, or? Now, I would have requested 13 because that's different. 14 is also a big issue. So let's do 9. Limit, as x approaches 0. E to, I think it's 4x, yeah. Minus 1 minus 4x divided by x squared. Ready? Or not yet? So when I plug in 0, 1 minus 1 is 0, 0, 0.
Wait, so you just your screen.
So therefore, I have to differentiate the top. L'Hopital's rule is applicable here. E to 4x is e to 4x times 4. This is 0, and this is 4, and this is 2x. I plug in again. I get 4 minus 4 over 0, so this is 0 over 0. So this is limit, as x approaches 0, from 16 e to 4x divided by 2. So the answer is? Good. Anything else?
So,
Yes.
I actually kind of want to add something that I think probably should have picked up and freaked out. So, the asymptotes, the horizontal asymptotes, the vertical asymptotes, it's kind of odd because you can look at a function and tell when it has a horizontal or vertical. But without really looking at the graph, it's a little bit tricky or trickier to find a slant asymptote.
No, you will have to use a long division or synthetic division depending on the oh, I forgot to show the synthetic division to find the slant asymptote. Now, there is a way.
I mean, you can do it, but like, is there sort of a set? Because when you're looking for the horizontal asymptote, obviously there is a method, the limit from negative to negative positive infinity on the plane. When you're looking for a vertical asymptote, it's usually well, actually there is there kind of isn't a set way for that one either, unless you're like dealing with rational functions or say the tangent, where you also well tangents also can be broken down rationally, and that like any denominator wherever it's 0, I'm assuming is where you can kind of smell that asymptote. But with the vertical, I'm guessing that's where you having the denominator, some sort of maybe binomial that goes into it that pulls out.
That is true. You could you could factor it a little bit so that you can divide, but we have long division or synthetic division available, so it will take you a minute to find the slant asymptote. Only rational functions whose numerator has a higher degree by 1 unit exactly than the denominator have slant asymptotes. You'll not find slant asymptotes for anything else. Just one type of function has a rational function has slant asymptotes. When the degree of the top is by 1 unit higher than the degree of the bottom. So you just use long division or synthetic division. And do you still want me to show synthetic division or look at another limit?
We can 14.
Yes, 14. So that is limit as x approaches. I think it says pi over 2 from the left. Am I correct?
Yes.
Okay. Tangent x raised to, it's cosine, right? Good. So what do I do? Yes. So remember the graph of tangent between negative pi over 2 and pi over 2. So the graph is this. So as x approaches pi over 2 from the left, this approaches, look at the graph,
Oh, positive infinity.
correct? So this approaches infinity, and cosine pi over 2 is?
0.
Yes. So infinity raised to 0 is a big problem. Ready? What do we do in this situation?
Natural log.
Exactly. I will say that this function is denoted by so I will say y equals tangent x raised to cosine x, natural log y equals cosine x times natural log tangent x. So now I apply limit to natural log y as x approaches pi over 2 from the left, which is limit as x approaches pi over 2 from the left of cosine x multiplied by natural log tangent x. I start again. I continue now with plugging in. So this approaches 0. This approaches infinity. Therefore, this approaches, yes. Now, this is much better. Infinity raised to 0 is awful, but 0 times infinity is much better. Okay, so then I have limit as x approaches pi over 2 from the left. Now I'm going to write natural log. Do not ever take natural log anywhere. But instead of cosine over 1, I write 1 over, or, what is 1 over, because when I flip it, I get the same thing. Well, what is 1 over cosine? Secant. So then this is limit. So x approaches pi over 2 from the left. Natural log tangent x, secant x. Coming back here because it's easier. 1 over 0 from the left is infinity over infinity. So, this is limit. Nobody can see. Limit as x approaches pi over 2 from the left. 1 over tangent x multiplied by secant squared x over secant prime is secant tangent. One of those two go away. So now I have limit as x approaches pi over 2 from the left from secant over tangent squared so pi over 2 from the left. So let me think for a second what we do. So what should we do with, yes. So let me see. Secant is 1 over cosine x. Tangent is sine squared over cosine squared.
So that'll be cosine x over
So exactly. So these two go away. So I'm left with cosine over sine. But sine at pi over 2 is 1, and cosine at pi over 2 is. So from here, I will rewrite so I have limit as x approaches pi over 2. Instead of secant over cosine over tangent squared, I will write cosine over sine squared. But this approach is 1 and this approach is 0, so the limit is 0. So now I'll write the beginning, which was limit as x approaches pi over 2 from the left from natural log y, and the end. I will swap the limit operator with the natural log. So natural log of this, limit as x approaches pi over 2 from the left from y. But I know what this should be, so that natural log of this number is 0. Yes.
I think that's pretty fantastic. Like how it all kind of.
Right? So what we had initially, yep, I had to go through all this. Very good. So that was 14. Any questions?
So I was sitting here working on 13.
So you're working on 13. Very good.
And we did 14, so
Very good.
13 real quick.
Let's do
This is
13.
all kinds of throwing me off.
Okay, let's do 13. So this is limit. This is 13 on page 352. The previous one was 14 on the same page. So limit as x approaches, I think it's 1, isn't it? 1 from the right?
Right.
Perfect. You cannot separate them. This is 1 over 0, and this is 1 over negative infinity. I'm sorry, 1 over 0. So I can do anything. I have to find the least common denominator, which is x minus 1 times natural log x. So therefore, this up here needs a natural log x, and this needs an x minus 1. So then x natural log x minus x plus 1. 1 from the right. This is 0 times 1 is 0. This is 1, negative 1 plus 1, so the top is 0. This is 0, and this is 0. Nice. So then, x approaches 1 from the right. I have to treat this as a product. X prime times natural log plus x times 1 over x, which is 1, and minus 1. Now this prime is 1 times natural log plus this times 1 over x. So x minus 1 times 1 over x. Any questions so far? These two go away. So limit x approaches 1 from the right, natural log x, natural log x plus 1 minus 1 over x. 1 x times 1 over x is 1, negative 1 times 1 over x. This is 0. 0 minus 1, 0. I have to continue. Limit, as x approaches 1 from the right, the top is 1 over x, this is 1 over x, this is 0, and this is plus 1 over x squared. Now it's done. 1 over 1 is at the top, 1 over 1 plus 1 over 1, 2 at the bottom. Better? Any questions? So let me give you a list of topics to think about and look back at, right? So of course, roles, the mean value theorem, of course graph, the whole thing. Also graph on an interval as we just did, on a closed interval. Newton's method, optimization, and I can't think of anything else.
We do an optimization.
Right. Yeah, well, we only have 7 minutes left. It's not gonna, yeah. So I'm just going back for a second. L'Hopital's rule, of course, limits.
So I was gonna head over to Debbie's after this, so if anybody wants to practice some optimization problems over at Debbie, if anybody has time.
So that's all we did. There is nothing else. The mean value theorem, Rolle's theorem, graphing, L'Hopital's rule. I just want to make sure I didn't forget anything. Graphing again, optimization, and Newton's method. There is nothing else. Any questions?